Hey, happy Wednesday, y'all. Oops, let me hide this. All right. Hey, so we're going to continue on talking about solutions. We've been talking about that, feels like all trimester. Today we're going to talk about something that's a really big word. Sounds like a lot, seems difficult when you look at it. It's not that bad, okay? We're going to talk about something called colligative properties. It's something that you already are familiar with. For those of you guys who did Facebook, or not Facebook, excuse me, Chemistry Live yesterday, we talked about colligative properties. Now, maybe we didn't even say those words, but we talked about solutions and how they change, and that's really describing what colligative properties are. So, um, things have certain properties. So on this picture here, there's some ice. Okay, now ice, hopefully you know this at this point, but ice is made of water, and there's certain properties you know about water, right? You know it's clear. You know that it freezes at 0 degrees Celsius. You know that it boils at 100 degrees Celsius. You know that when it's frozen, it's less dense, and that's why it floats on top of the water. You know, if you heat it up over 100 and it boils, it changes states of matter from a liquid to a gas. You know all these properties about water. However, when you turn water into a solution, remember water is usually the solvent, right? It's the thing that does the dissolving. When you turn it into a solution, it changes the properties, okay? The changing of these properties are what we're going to call colligative properties. When you create a solution, you have new properties. And that's what we're going to look at, okay? So here's what we're going to do. We're going to go through this PowerPoint. It's not very long. I think it's like 7 slides. I'm going to fly through it. Do your best to get it filled in, filled out. In the Google Docs, I have a doc that goes right with it. So you can, again, as we've always done, you can type it in, you can write it on paper, take a picture, however you want to do it, just turn it in, easy, simple. I'll go through all of the questions, okay? I'm also going to show you today something called a solubility curve. And you might not know what that is now, but by the end of this little talk, you will, okay? So let's roll. Oh, last thing before I forget, if you did not do Chemistry Live on Tuesday, I only had 4 people do it in the morning yesterday. If you didn't do it, you need to do it on Thursday. I'm just telling you, if you come and check in, it's 20 minutes. I'm not going to embarrass you. I'm not going to ask you. I'm not going to call you out. I'm not even going to ask you to fill anything out, but if you attend, right, whatever that means online, if you attend that Chemistry Live, you get full credit. If you don't, then you're going to have to do some actual lab work. So tomorrow, 1 p.m. is our last chance to do the Chemistry Live. So just a reminder on that. Okay, so here we go. Let's talk about colligative properties. Oops, let's move along here, see if I can get this to work. Okay, so what do we want to do today? Here's our learning target. I want you to be able to move that aside, be able to read and interpret what's called the solubility curve for a given solution. And so I'm going to show you what that looks like, but that's our learning target. You should be able to read and interpret or make sense of a solubility curve. Okay. All right. Maybe not. Okay. So if we're looking at solubility curves, remember what solubility is. Solubility basically tells me if a compound can be dissolved or if it cannot. So there's 2 words. We've already learned these. These are review. But remember, soluble and insoluble. Soluble means it can be dissolved. So for example, sodium chloride or salt, table salt, we put it on our French fries, it can be dissolved in water. So we would call that soluble. Oil, on the other hand, if I put oil with water, it cannot be dissolved. And so we would call that insoluble. So those are 2 words. So when we're talking about solubility, we're referring to, hey, this can or it cannot be dissolved. Okay, so just 2 words. Just want to remind you of those. Now, before we go on and I show you the curve, there's 3 new words for you. They're all close and similar. They are saturated, unsaturated, and supersaturated. So notice the root word is the same, saturate. The word saturate means full. So if you have a sponge and you dip it in a tub of water and you pull out the sponge, it's going to be full. We would call that sponge saturated. The sponge, is full of water. It's saturated. Okay. So the word saturated means it's full. So look at what it looks like in terms of solubility, in terms of dissolving. If I have a compound, if I have a solution and it has that compound is dissolved in water, it's formed a solution. If there gets to a point where I can only dissolve so much, there's what we call a max capacity. If I get to that max, it's saturated. Okay. So if I'm making Kool-Aid, and we've used that example a lot, and I told you already, man, I like mine with a lot of sugar in there. And I put in sugar and I put in sugar and I stir it and I put in sugar and I stir it and I put in, I stir, right? Eventually it's going to stop dissolving. When I get to that point, we say that is saturated. It's full. It's at the max capacity. Okay. If I've put in a little bit, but it's not full and I could actually dissolve more yet, I would call that solution unsaturated. It hasn't reached that max capacity. It's not full. Un means not, saturated means full. The third is supersaturated. If I keep adding and adding, adding, and I stir and I stir, and I get past that saturation, that max capacity, on the bottom of the Kool-Aid, I'm going to have chunks on the bottom. I have sugar on the bottom. I won't be able to dissolve it. That is a supersaturated solution. It is over the max capacity. Now I can keep adding sugar till it starts coming out the top, but anytime I'm over that saturation, over that max capacity, we call that supersaturated. Okay, so saturated, max capacity. Unsaturated, haven't gotten there yet. Supersaturated, I'm over that capacity. Okay, 3 new words. Last thing, we're almost done. Last thing I want to show you is this thing called a solubility curve. Okay, so before I move on, I want you to take a look. Whenever we have a graph, you want to look at the axes, the X and the Y. So in the vertical, the Y axis here, it's labeled just, I don't know if I can write, it's labeled just solubility. Okay, and then in parentheses, it says grams of salt in 100 grams of water. So it starts at 0, it goes all the way to 100. That tells me how much salt would get dissolved in 100 grams of water. Now, we've been talking about Kool-Aid, but salt also dissolves in water. Now, table salt for us is NaCl, but all of these on this graph here are types of salts. They're a metal and a non-metal. They're an anion and a cation. They form what's called a salt. Okay. The other axis, the horizontal, the x-axis, it says temperature. Okay. So there again, I go from 0 to 100. Now we're dealing with water, so I'm going from freezing 0 to boiling 100. So anytime that water is in the state of liquid, that temperature is represented. Okay. So when I move to the right, I'm getting hotter in temperature. When I'm moving up, I can dissolve more of the salt in the water. Okay, now before I move on, I want you to notice the overall trend here. There's different colored lines. The colors stand for different salts. I've labeled what salts are what, but if you look at most of them start at the bottom and then move up and to the right. Now, what does that tell me? Now, there's one weirdo, right? There's the one at the bottom, cesium sulfate, starts top left and ends bottom right. That's a weirdo. That's a little bit of an exception. But the rest of them, notice it's a direct, remember talking about that, it's a direct relationship. As temperature goes up, solubility goes up, or vice versa. As solubility goes down, temperature goes down, right? So the overall trend is that when we increase temperature, I can dissolve more. And we know that to be true. And this shows that. Okay. But they don't do it at the same rates. It's different depending on the salt. Okay. So let's do a couple interpretations. I explained the graph. Now can we interpret? Can we make sense of it? So we're going to do 4 and then we're done. So question 1 says, what's the solubility of potassium nitrate at 30 degrees Celsius? So potassium nitrate is KNO3 right here. It asks, what's the solubility? So again, remember the left-hand side is solubility, and I gave you the temperature. Temperature's at 30, so I'm right here. So how do I figure that out? Well, what I do is I know the temperature. So I'm going to take that temperature, 30 degrees, and I'm going to take it up, stay on that line, until I hit potassium nitrate. So I'm going to, now in this case, it's the green one. So I'm going to go up, 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 boom, and I hit it. Okay, once I hit that line, then I'm going to go over to the side to where it says solubility. I'm going to follow that over. It looks, I would say somewhere in there, maybe 44, 45 grams. Well, how do you know it's grams? There it is, right? So the answer for this would be 44 grams. And what does that mean? That means if I have potassium nitrate in 100 grams of water, and it's at 30 degrees, the max capacity would be about 44 grams. I could dissolve 44 grams of potassium nitrate as long as it's 30 degrees. Now, what happens if I ramp it up to 50? If I heat it up to 50, well, now look, now I end up whoa, okay? I might get 90. As temperature goes up, I can dissolve more, okay? But this one asks for 30, so the answer we have is 44. Okay, we're 1 down. Let's do the next 3. Next one says, how many grams of sodium chloride can I dissolve in 100 grams of water at a temperature of 45 degrees? Whoa, that seems like a lot. Same question. Well, wait a second. I see this 100 grams. What is it? That's already in here. Notice on the left side, it already says 100 grams of water. So don't let that throw you off. What is it asking for? How many grams of sodium chloride? NaCl, salt. Okay, so I got to find that curve. This one's light blue. Here it is. Okay, and what's the temperature I'm looking for? I'm looking at 45 degrees. So again, I got to look at the bottom for temperature. Whoa, no, what happened? Okay, I got to look at the bottom for temperature. Say, all right, temperature 45. There it is. Oop, come on, let me write 45. I don't want yellow. There we go. 45. I'm going to go up until I hit sodium chloride, which is light blue. So I'm going to go up, 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 up. Boom, I hit it. Okay. And then I'm going to take it across right at that spot. And I'm going to go I don't know, somewhere in there. I would say, I don't know, 36, 37 grams. So if I have water, 100 grams of water at 45 degrees, I can dissolve 36 grams. That's the solubility. That's when I got max capacity. Well, what happens if I put 38 grams? Well, now I'm over that, right? What happens if I put 50 grams? I'm over that. I'm super saturated. What happens if I just put 10 grams? I'm under that. I'm unsaturated. But when I get right to that line, I'm at the saturation. I'm full. I can't dissolve anymore. Okay, 2 more. Here we go. Now, this is kind of the opposite. Now I'm not asking for how much can dissolve. I'm asking for what temp. So again, I'm using that sodium chloride, that light blue line, but now it says, at what temp is the solubility of sodium chloride the same as potassium chloride? Oh, shoot. So potassium chloride is the dark blue line. Is there anywhere where those 2 lines intersect? So I look, sure enough, right there. The dark blue and the light blue intersect, okay? So I got to find out, well, what temperature? So, well, temperature, remember, is at the bottom. So I'm going to find that intersection, and I'm going to go down. There it is. Looks like to me that they intersect at 30 degrees Celsius. So what does that tell you? At 30 degrees, I can dissolve the same amount of sodium chloride as I can potassium chloride. They have equal solubility. All right, last one. What compound is the least soluble at 40? So look at all of these. 1, 2, 3, 4, 5, 6, 7, 8. There are 9 different compounds on here. Which one is the least soluble? So again, solubility is on the left. Which one is the lowest one at 40? So here I go to 40 and I go up. Whoa, I don't go very far and I hit 1. That's that weirdo, right? That's that one that goes opposite trend of everybody else. That's that Ce2SO4 3. So Ce2, that's cesium, SO4 3 sulfate. Cesium sulfate is the least soluble compound at 40 degrees. Done. Okay. So this is a really good example of, number one, a solubility curve, and number two, how do you interpret that curve? That's all I got, guys. So fill in that sheet, or maybe you wrote it down on paper. Fine, take a picture, send it to me. Make sure you click the turn it in button. You're done. Awesome. Way to go. You did it. Proud of you. Remember, tomorrow, Chemistry Live. All you got to do is attend, and you get full credit, but you got to show up. Okay. All right, guys. Sounds good. See if I can get out of here. Appreciate you. Love you. We'll see you on the flip side.